right, so 18 said that we want the LCM of 4 and 16. All right, so we need to find the prime factorization of both of them. So 4 is 2 times 2. 16 is 2 times 8, which is 2 times 4, which is 2 times 2. Or however you could have done, 4 times 4 and gotten the same thing. All right, so 4 is equal to 2 times 2. 8 is equal to 2 times 2 times 2 times 2. Okay, so whether we're doing GCF or we're doing LCM, so far this is the same process. What did I do wrong? Thank you. Yep. Thanks, Danny. Excellent. Thank you. Okay. So when we talk about our LCM, we use every prime factor that's in there and the most from any one list. Well, the only prime factors showing up are 2's. There are 2 2's in my 4. There are 4 2's in my 16. So I need to use those 4 2's. All right. Well, this is going to be 2 times 2, which is, well, we know that's 16 because we already knew that that was 16. So it's the most from any one of your lists for all of them. All right, let's do another one to make sure you understand this, whoever needs help with this. All right, so let's do 20. All right, so if I take a look at 20, I want to find the LCM of 21 and 14. All right, so 21 is going to be 3 times 7. 14 is going to be 3, let's change, I'm going to do another one for you guys. It's going to be 2 times 7. So 21 is equal to 3 times 7. 14 is equal to 2 times 7. My LCM is going to have a 2 in it, a 3 in it, and a 7 in it. Well, the most number of 3's from any one of my lists is that 1. The most number of 2's from any one of the lists is just that 1. The most number of 7's in any one of my lists is just 1. Now, you don't have to put 1's there. I do because I know that makes me know that I went through and counted them. It's kind of like a double check for me. So this is going to be 6 times 7, which is 42. Are there any other ones you guys want me to do? Cameron? Which one? 56. All right, let's take a look at 56. Addison, if you have another one you want me to do, I'd be happy to. Okay, so 56 said, I want to find the LCM of 24d e squared and 36d cubed e. Is this the one you're talking about? Awesome. All right, so I'm going to go ahead and do the prime factorizations of the numbers. Cameron, what did you have with 2? What did you start with 24 there? 6 times 4. What's 6? So 2 times 3. And what's 4? Excellent. 2 and 2. Cameron, do 36 for me. Okay. And they're both going to be 2 and 3, right? All right, so now I'm going to list them. You guys, even if you got these right, you're making sure that you're listing them right. It is really important to me that when you list these, that you include the variables. So 24d times e squared is going to be 2 times 2 times 2 times 3 times d times e times e. And then 36d cubed e is going to be 2 times 2 times 3 times 3 d e. All right, so my LCM is going to equal 2's times 3's times d's times c's. Those are all the prime factors that are in there. Now I have to figure out how many. So Cameron, 24 has 3 2's I'm multiplying together. 36 only has 2 2's that I'm multiplying together. So I'm going to account for those 3 2's. So I have 2 cubed. That first one, 24, only has 1 3. 36 has 2 of them. So I'm going to use those 2 3's. So that's 3 squared. There are 3 D's being multiplied together in this list, so that's D cubed, and there are 2 E's being multiplied together in this list, so I'm going to use a 2. Are you cool with that? Okay, so 2 cubed, 2 times 2 is 4 times 2 is 8, 9 squared is 9, D cubed E squared, so this is going to be 72 D cubed E squared. Does that help you? Yes. No, I don't have to see I'm okay because you're comparing the ones that have the same denominator. I would leave them with the same denominator when I compare them. I know the answers in the book have them going back. I don't. No, I prefer that you leave them with the right denominator so you know which one is smallest and biggest. You know what I mean? Yeah. Matthew. Just do one. Give me one. 40. So let's take a look at 40. All right, so if we take a look at 40, you don't have to use the least common, you don't have to use the least common multiple as your common denominator. You just need a common denominator, okay? It doesn't matter to me what denominator it is. That's the one thing I do want to point out to you. It just has to be a common denominator. So we have 2/3 and we have 5/8. So if 24 jumped in your head, that's fine with me. If something bigger jumped in your head, that's fine with me. One of the things I do need to see is I do need to see you showing me that equivalent fraction work. So 2/3, I'm going to multiply by 8/8 to give me 16/24. And then I have 5/8. I'm going to multiply that by 3/3, and I'm going to get 15/24. So now if I list them in order of least to greatest, I have 24ths, not 25ths, is smaller than 16/24. So that is an order of least to greatest. So this is the work I should expect to see, which is what we've been working on with equivalent fractions. Yes? I think it said use to see which is greater. Oh, they just want to know which was greater. So that one was greater. It didn't say least to greatest. I thought it did. I didn't read it. Use least common denominator to determine which fraction is greater. So read the directions. What else can I do for you guys? Ada? Give me one. 44? Excellent. So 44 said I have 7/20ths and 9/25ths. So what common multiple do these two have? Yeah, 100. So I'm going to use 100. So I need to see off to the side the math involved with writing those two fractions with a common denominator of 100. This is always what I want you showing when you're doing equivalent fractions. Ada, what am I going to multiply 7/20ths by? Excellent. So that's 35/100ths. And what am I going to multiply 9/25ths by? 4/4. Don't forget, it has to be 5/5 and 4/4, not just 5 and not just 4. All right, so my 36/100ths is bigger. You guys cool? You guys good with all these? Excellent. You have a homework quiz. So get a piece of paper out and a pencil. You do not need your